Morning all. In our previous lecture, we were discussing important properties and theorems of Z transforms. Now, in association with that, we will be continuing with that same lecture. In our previous class, we have discussed the multiplication by a constant, the important properties. Multiplication by a constant A, that is, if what the Z transform of A into x of k, where A is a constant, is nothing but A into x of Z, when by definition we have x of Z is equal to sigma k is 0 to infinity x of k Z power minus k. That is by definition. Therefore, multiplication by a constant of the same function, same sample data signal, A into x of k will give you A into x of Z, and the linearity property, we have discussed this. The linearity property here, the Z transform of alpha x of k plus beta y of k, where alpha and beta are constants, you have alpha into x of z plus beta into y of z. This will happen if and only if Z transform of x of k is equal to x of z and Z transform of y of k is equal to y of z. This will happen only when Z transform x of k is equal to x of z and Z transform y of k is equal to y of z. Therefore, Z transform alpha into x of k plus beta into y of k is equal to alpha x of z plus beta y of z. That is the linearity property. Now we will also see multiplication by a polynomial function. Multiplication by a polynomial function. We have already seen this yesterday. That is our third one. Then Z transform of a power k x of k is given by x a inverse z. This is what we have seen yesterday. When any function, any sample data signal is multiplied by a power k, which is a polynomial function, then you have x of z by a or a inverse z. These are the important properties that we have seen in our previous class. Now we will see the important theorems, the theorems of the Z transforms. In that we have started with the shifting theorem, where any signal is time shifted. One is the time delayed signal, and the other is the time advanced signal. That is, a signal, if a function u of t is shifted by 1 second or t seconds, shifted, this is delayed, then it is u of t minus t. Now, if any function is advanced by t seconds, then it is u of t plus t, when this is t and 0. Now, this is a time delayed function and time advanced function. Now, we will try to see what is the Z transform of a time delay function and a time advanced function. For example, let us say we are having any function x of t minus t, or I will try to generalize this statement t minus nt. What is this Z transform of x of t minus nt, which we get z power minus n x of z. The proof for this is what we will have to discuss now. The proof of Z transform x of t minus t, by definition of Z transform of x of t minus nt is given by sigma k is 0 to infinity x of kt minus nt z power minus k. Now say k minus n is equal to m. Then by replacing that in the above equation, we have z transform of x of t minus nt gives us sigma x of k minus n is m t z power. What is k? It is m plus n. M plus n. Now we have to look into the initial and final values of k. Now when k and m, we are concerned with k and m in terms of n. When k is 0, what is m? It is minus n. According to this equation, when k is 0, m is equal to minus n. When k is infinity, m is equal to infinity. Therefore, you can write here m is from minus n to infinity. Now we know that we are considering all one-sided z transforms. We are considering all one-sided z transforms, which indicates that x of t is equal to 0 for all t less than 0. So therefore, for all negative values of m, now m is ranging from minus n to 0 to infinity. Now during this period, x of t is equal to 0. Therefore, without loss of generality, we can replace n minus n with 0. Therefore, you are having this equation. With this equation in mind, we can see that we can just try and separate this sigma m is 0 to infinity x of mt z power minus m into z power minus n. Now this can be pre-multiplied here. Therefore, you get z power minus n sigma m is equal to 0 to infinity x of mt z power minus m. You can call this as z power minus n x of z without any losses. And therefore, the proof for this is obtained. That is, z transform of x of any time delayed function is z inverse x of z. Now we will see a time advanced function. Hope you all have understood the proof for the time delayed function. Now we will consider any time advanced function x of t plus nt. What is the z transform of x of t plus nt, which is nothing but z power n x of z minus sigma k is equal to 0 to n minus 1 x of k z power minus k. Now we will have to prove this theorem. The theorem goes by definition, z transform of x of t plus nt gives us sigma k is 0 to infinity x of kt plus nt z power minus k. Sigma k is equal to 0 to infinity x of kt plus nt z power minus k. That is by definition we are going to get like this. Now if I add sigma k is 0 to n minus 1 x of kt z power minus k and subtract the same term here, k is 0 to n minus 1 x of kt z power minus k. If I add these two terms, I can combine these two equations like this.